Hey, it's us
Hello!
again.
It's us again. Welcome to You Choose, the Choose Your Own Adventure style show through the whole CNCF landscape, more or less. We're doing our best.
More or less. I
Yeah.
mean, that's the idea. That will never be accomplished. I
Not
can
with that
only hope.
attitude. So we're on chapter 3 security and we're coming to the end, which makes me a little sad, but also I feel a good sense of accomplishment. I know so much more than I did 2 months ago. I, It's we've had this is our 10th episode of chapter 3 security. We've gone over a lot of security projects. And this episode is just those stepchildren, the weirdos, the ones we didn't know where to put them.
I mean, look, Whitney, you're sitting with your back in a corner over there. That doesn't give me a feeling that you feel any more secure than before. Kind of like, that's not the attitude.
I can
That's
I can see everything.
exactly kind of like nobody's coming at you without you noticing. So there you go.
Maybe yeah. Or I exactly feel more secure because I know how to stand in the corner and I didn't before.
That's not that you feel more secure, you feel more paranoid. Yeah.
So we're finishing up chapter 3, and then we'll take a break from You Choose for a while. This is going to be our last episode with guests, and then next week is KubeCon. And on Wednesday, Victor and I are going to do a Choose Your Own Adventure talk next week at KubeCon, where you can vote live, and Victor will build the demo on the fly. And for that one, we're only doing some of the choices. We don't have time to do every little thing. And then on Friday during KubeCon next week, so a week from this coming Friday, we are live streaming our final episode of You Choose, which will be a recap of everything we've gone over so far. So it will be a doozy. It'll be a long one, but we're going to live stream it from the floor of KubeCon Expo from the Tanzu booth on Friday at 10:30. So if you're at KubeCon, come hang out, especially
I
if you
mean,
were a guest before. Yeah.
when Whitney says we are going to stream from KubeCon, what she really wants to say is that there is a chance that we will stream from KubeCon. And there are many things that can go wrong. We might not have Wi-Fi. Microphones might not work. I would say statistically, it would be safer to say that we will not stream from KubeCon, but we'll see. Hope
We
dies
will do our
last.
best. Well, and then there are a lot of things we'll try to do to make it our equipment have good quality. I think those will go before the stream itself. It might be a terrible sounding stream with terrible lighting, but we're there talking about the tech. Or it might be, professional lighting. Our voices sound buttery and amazing. Already I had like professional mics that broke and I'm just using my AirPod mics right now. We do what we can. It's anyway, I'm super psyched for KubeCon. Those of you who are with us live, if you are going to be at KubeCon, please say hello. Even if you're not, we have hello. I'm glad you're here. So today we're talking about some weirdos. I like the
Yep,
weirdos we have on
that's
stage very
the
much. They're very kind weirdos.
exactly.
Yeah.
That feels
The
now I feel
misfits.
comfortable. Finally.
We're with our people.
Yeah. They couldn't be placed in a box. Excellent.
But first, before we dig into this week's tech, let's do a recap of last week. Last week we talked about different authorization tools. So let's go over the tech. Because they all covered very different things. There wasn't different parts of authorization. They were very different from one another, the tech last week.
Yes. Well, what were they? I remember OpenFGA. That's what I do remember.
Yeah. I wonder why. One was Hexa. So Jerry Gable is here to talk about Hexa, and Hexa has they came up with the identity query language, IDQL, that is, so you could write access policy in one language and then apply your policy to lots of different providers across the cloud. So you don't have to have specialists in each one.
That one is actually pretty cool. Underrated, if you ask me, because larger companies, they have more than one authentication, something, right? So yeah, it's pretty cool one. Maybe not for tiny companies, but when you go bigger, it's a good one.
Yeah. And then the other one, then OpenFGA, and then Perilous was the other one. Saeem Safdar came on and talked to us about that.
Yeah, Perilous is mostly about giving access, probably temporary access to your Kubernetes cluster or one of the clusters, right? And okay, here's you go there, you authenticate yourself, and depending on who you are and what you can do, you get kubeconfig, and with that kubeconfig, you can perform certain operations, whatever was decided.
So it seemed to me that it was like a centralized dashboard. There was a GUI, there's a CLI, there's an API, a centralized place where you can manage access, RBAC specifically, to one or many Kubernetes clusters. So it seems especially useful to me if you're trying to manage RBAC for a lot of clusters at once.
Exactly.
Being able to do that. So those, and then the final one was OpenFGA. And tell us what you learned about OpenFGA.
It's pretty cool. It's very simple. Unlike some others, which I'm not going to name, it has documentation that actually makes sense. It's easy to learn. And this is the part where I start drooling, kind of no UI. People freak out because there is no UI. To me, kind of no UI, great. Terminal. So I really like it. I really liked it.
So the FGA
I don't say that often for security type of tools.
Those of us who watch the show regularly know this is true. The FGA of OpenFGA stands for fine-grained authorization. And so this tool is a tool meant for developers, and it stores relationships in a model, in a relationship model. So basically, it has, if you want to add logic into your application where it matters who can access what, so like a Google Drive, for example, would be a good example, then you can do that. And unlike attribute-based access control, since it's stored in the model, it already knows the relationship. You don't have to do a search for data. You don't have to do any computes for figuring out what the relationship is. It already knows. So it makes it a lot faster, and it makes it so you can bring that logic out of your application and manage it as part of OpenFGA instead.
Exactly.
And so
basically, essentially from application, you just say, hey, can this user do this? Right, and depending on the response that you get from the OpenFGA server, you do something or not.
Yeah,
that's my explanation of it from the application perspective. Now, management is very different. We'll see it in a second.
So, Victor, which one won?
Maybe.
I have no idea. I can't.
Yeah. There we go. OpenFGA.
OpenFGA. Yay. All right, let's see an
Okay, you can see my screen, right? So there will be a bunch of commands today, right? And I will copy and paste them just to save some time from typing for a long time. Basically, what I'm going to do here is I'm going to first create a store, right? So one server can have more than one store. Think of it as groups of models, which we're going to see soon. So I'm going to create a store called DOT. I'm going to extract the ID of the store, which I will need later, and I will put it in an environment variable FGA store ID, right? Now, FGA, we can list the stores list, right? Here you will see that there is a store DOT, that's the one I just created, right? Think of it as a database within a database of sorts, right? Now, next, once you create a store, you want to create a model, right? OpenFGA model, there we go. This is a simple one, nothing really special. What I'm doing here is saying, hey, there is something called document, and inside of the documents, you can have a reader and writer, and that's about it, right? And then there are relationships, which is essentially in this case the same, right? So what really matters in this model is that I will have a reader and writer for a specific document, whatever the document is. In this context, you can think of document as an application, right? Now, I will now send that to OpenFGA, right? This is all, as far as I know, there is no UI, right? So you managed everything through the API. I'm going to say, hey, model, write to this store, the one that I just created, write that model, output the ID of that model, and store it in this variable, right? We will need it in a second. What the heck? What did I do wrong? Most of the time it fails, but not this fast. Okay, let's see. That's okay. Maybe the store ID echo. The store ID is correct. I'm going to write this model. Okay, there is something wrong in the model. I'm going to check it. That's why I hate JSON. There is an extra comma over there. Extra comma. Horrible. Okay, now it will work. Look at it, right?
Beautiful.
And I'm going to store that model ID into FGA model ID variable. Okay. Did I say that I don't like JSON? Now I do. Anyways, here we go, right? So if I list the models, you will see that there is a model now that we specified with very simple one, with reader and writer. And now comes the important part, right? I'm going to say, hey, in that store, and for that model, I want to add a user called vFarsic, and that's me, and that one will be a writer. There are two roles that we can have, and writer for the document called silly demo, right? That's the application that we are going to use today. And I'm going to create another one and say, you know what? I'm going to be a reader as well. This is the same, just I'm going to be a reader. I could actually assume that writer is a reader, but it doesn't matter. And the third one, just for testing purposes, this one is not vFarsic, it's sFarsic, different user that will be able to read silly demo, but I will not give that user write permissions. So that user will not be able to write. And finally, there is code changes that I had to make, right? This is the code, it's Go. The logic is the same. It supports 5 languages, I think, or something like that. I have here a check that says, hey, go to get the user and the relation and the document, silly demo in this case, prepare that request, send it to the server, and return whether that is allowed that user, right? So whichever user I send through a request will be propagated to the server, and then OpenFGA will tell us whether that user is allowed to do that something, right? Whatever that something is. And I have this relation is a variable, so you will see later in that I will be sending relations like, hey, can this user write to a database? Can this user read from a database, and so on and so forth, right? Now, that's about it. Now, what I'm going to do is that I'm going to modify very quickly. I'm going to copy and paste. I'm going to modify the application to add a couple of variables. Ingress doesn't matter, stuff like that, but I'm going to propagate now to my application the store ID and model as variables, so that my application knows that that it should use that specific model and that specific store. And I'm going to generate my Kubernetes manifest using YTT. And the reason why I'm using YTT is because that's one of the...
what you chose.
Exactly. In the first season, early on, right? So I'm generating YAML. This is nothing special. Let me find it. Just where is it? Ingress. No. Here, you can see basically the only thing I did is add to the application those environment variables so that my application knows where the server is and what is the store ID and model ID, right? Then I'm going to add that to Git, commit -m something or something, and push. Now, this will be now synchronized with Argo CD, and the reason why we are using Argo CD to synchronize is the same reason why we are using YTT, and that reason is because that's what you chose in one of the previous episodes. And what is the ID? 5959. I'm just checking whether it's okay. It's synchronizing it right now. I'm on a different screen. You cannot see it, but trust me, it's ongoing. Okay, we should see now. If I look at my application, if new pods were created, namespace production get pods, we should see application. There we go. 12 seconds ago. Okay. Application was redeployed. Now it knows about FGA, and now I can do some stuff. So now, before I do some stuff, let me give you explain something very clearly. I'm now dealing with authorization, not authentication, right? So imagine that there is a separate process in my application that is making sure that when I say that I'm vFarsik or John Doe, that's really true, right? We're skipping that part, mostly because I was lazy to prepare it, and this is about FGA, right? So FGA does not validate that you are who you are. It just assumes that you are who you are, you validate it somewhere else, and then it tells you whether you can do stuff, right? Now, can I send the request to check the videos in my database? No. This is my application now saying that it's not allowed to send, to communicate with the database without putting user in the query, which is what I'm going to do now. Same query, just I'm saying I'm user John Doe, right? Again, I'm skipping authentication, right? And John Doe is not allowed. This is my application saying you cannot do this, not allowed. If I send the same request with sFarsik, that's a person who, not me, some other person that can only read, cannot write to the database. So, and that worked, right? Actually, it didn't. My database is not set up, but if you see the error from the database, that means that authorization worked. That's the problem. That's the point. Authorization worked. This is now my application failing. Doesn't matter. What does matter is that if I try with that same user, sFarsik, to write something to the database, the answer is no. Yeah. If I try to write to the database as a different user, vFarsik in this case, the answer is yes, but Victor did not configure the database. Right? Now ignore the errors with the database. That's not the subject today. The point is that I'm allowed or not allowed to do things depending on the model and the tuples. Tuples were when I said, hey, this person in this model is a writer or reader or whatever. That's it, right? It's very, very easy, relatively straightforward, as long as you understand that you're not getting authentication. That's a different tool, and most likely that would be Keycloak, because that's what you chose last week, and I should have prepared it today, but I didn't. That's all. That's it.
That's it. That's beautiful. That was wonderful. That was fantastic. Thank you. So now we're on to this part of the episode is where we talk about why do we do this system design step. But the system design step today is the theme of the show today are the technologies that didn't fit into any of the system design steps of previous episodes. So these are the misfits, or as we kept saying at the top of the episode, the weirdos. I like the weirdos. Yeah. So let's bring them on to introduce themselves, shall we? So first up, we have Suraj. Suraj, tell us about yourself, please.
Hi, I'm Suraj Deshmukh. I work for Microsoft, but I'm fully working on the project called Confidential Containers upstream. It's a CNCF project, CNCF sandbox project. We'll hear about it in a bit. But and if you're at KubeCon, come and say hi. I have a couple of talks showing how confidential containers can help a bunch of CNCF projects like you guys are doing. So we'll try to integrate other CNCF projects with Coco. So yeah, that's me.
Awesome. So COCO is short for confidential containers.
That's right.
Cute. Got it. All right. Thank you. We'll see you shortly for your presentation. And next up, we have Rashid. Rashid's representing ContainerSSH. Tell us about yourself, please.
So my name is Rashid. I'm a freelance working in, let's say, mostly everything around cloud computing and that kind of stuff. CNCF ambassador since last year. And obviously, I'll be in KubeCon next week. So if you have any topics, just join me there and have some fun.
Excellent. I'm so into having some fun. Awesome. So we'll see you shortly for your presentation.
Yep. Absolutely.
Thank you. All right. Here comes Suraj. I'm going to add Suraj's screen. And as soon as you get started, Victor will start the time.
No, I'm going to start the time now, and you can start whenever you want.
Oh, okay. All right. So yeah, this is more of a 101 of confidential containers. I think we already did about me, so I think we can skip that. So let's start with something called as isolation. When we are talking about applications running on some kind of infrastructure. Now this application could be an app or a pod or a VM or a function, anything. This red boundary that you see is where your stuff stays, you as a tenant or user or whatever, right? But generally what any infrastructure provider wants is they want to provide isolation so that you don't break out of this thing and disturb others. But what about them? Them as in whoever owns the infrastructure, whoever owns the cluster, can they still see the stuff? I guess they can, right? Because they own it. We don't know what kind of access control they have. It's an untrusted world out there, and that's where confidential computing comes in. So confidential computing is turning this isolation stuff into confidentiality, where anybody on the outside, like the orchestrator or infrastructure or other applications, if they break out, like other applications, if they break out, they cannot see what's going on inside. Your data stays safe, and even if they read it, it's encrypted and stuff. So we'll look at it in a bit. So they cannot see essentially what's going on inside your this red boundary. So this boundary acts as boundary for isolation and boundary for confidentiality. So with that context in mind, let's dig deeper. Like, what's confidential compute again? So today, when we think about data, it's encrypted when you store it on disks. It's encrypted when you're sending it over network, like it's like we have SSL and TLS for a while now. It feels like it's natural. Before it wasn't. But when we are using the data, it's still unencrypted in memory. Anybody who, let's say you're running a VM and your application is being processed, like wherever it was, it came encrypted, it was stored encrypted, but now it's processing in memory on that machine. It's like anybody can read it. So that's the value addition that confidential compute provides. Your memory of the process or VM is encrypted now. So how this is done? So what confidential computing is giving you essentially is like giving you protection of data in use, and all you have to do is like trust the processor, and everything in between you can stop trusting. And this is enabled using something called as the enclaves. Now this enclave could be a VM or a process backed by the processor, and processor knows how to encrypt, decrypt the memories. Only the process inside the VM or processor can see it in plain text. Everything outside or everyone outside cannot. So earlier, when your application is running, right, like your guest and everything below it, like the hypervisor, operating system, kernel, the firmware, everything, you have to trust this whole thing. I mean, even if you don't control it, somebody else is keeping it up to date or whatnot. But with confidential compute, you can stop trusting everything in between, and like this whole hypervisor to firmware thing, and you just trust yourself. Obviously, you have to trust yourself to keep everything updated, and you trust the hardware, the processor. So Yeah, that's so a lot of things are going out of your trust boundary, which means lesser attack surface, which means secure applications or secure data. So what are the use cases, right? Like these are like main kind of use cases. This is not an exhaustive list. So there could be like multi-party computation where multiple parties have their data coming in, and you're trying to process together. So you can have this attestation going on, and then compute on the same set of data. There could be legal requirements where data has to be encrypted when it's being processed, or it could be just intellectual property protection, right? So how do you really know this memory is encrypted? So that's where
20
remote
seconds.
attestation. Oh, really? Okay, that's where remote attestation comes in, and yeah. So there is this process that goes on. So I'll skip this part, and I had so many slides going forward, but like I'll go to the main kata confidential compute part.
You will not. You will not.
Okay.
I don't usually feel bad, but you had so much more to say.
Yeah.
Actually, it's partly your fault, Whitney, because last 15 seconds, if you didn't say 15 seconds, he would at least say something. Right? You're like, 15 seconds, and you blocked the person completely.
My favorite, I don't know, I think maybe we got a lot, or at least maybe help me look into...
That wasn't 5 minutes,
no.
come on.
My favorite part was when you said, you have to trust yourself. We can't save you there. All right. I see a lot of questions coming through about confidential containers, so I think you'll get a chance to talk more, hopefully, about the stuff that you missed.
Yeah.
And we'll see you again shortly. Thank you. All right. Next up is Rashid. Welcome.
Yeah, welcome. And there we go.
So here we go.
Yeah. Starting now.
I know, yeah. So let's skip this part. I've already introduced myself. So what is ContainerSSH? Basically, ContainerSSH is an SSH server. What is interesting is that when someone connects to the SSH server, it then starts one or more containers, meaning really useful when you want to build labs, bastions, or you just want to let your users having some kind of a ephemeral environment they can play with, and when they disconnect, the whole environment dies. Runs on Docker, Kubernetes, Podman, highly configurable. You have webhooks. You have OAuth if you want to authenticate your users via GitHub, Google accounts, that kind of stuff. There's a lot of, let's say, configuration that you can use from out of ContainerSSH. You can use it as an SSH proxy and that kind of stuff. To summarize this, so the project has been donated in September 2022. It's in Sandbox. You can see it in the screen. And it's really an interesting product. How it works under the hood, it's very simple. So what you have in the screen is someone that logs into ContainerSSH in red. ContainerSSH sends the authentication, let's say, query to the auth server, and then the auth server, let's say, replies. Then ContainerSSH goes to the configuration server, and the configuration server tells ContainerSSH what it should do, triggering whatever the containers you want to use. Let's switch to a quick demo then. Before that, so let me show you the basic configuration. So this is a Kubernetes YAML that I've built. You have the configuration.yaml that will be used by ContainerSSH. And as you can see here, I just started a few containers. So there's shell, there's MySQL, and a mockun, which helps into mocking APIs. So how it works. This is my Kubernetes cluster. I have a lot of stuff doing here. I have my ContainerSSH that has been already deployed. If I go into services, what's interesting is I have ContainerSSH that listens on localhost, so on my machine, on port 2022 that I can use. And if you can see here, I'm in where is it? I'm in the ContainerSSH guests. This is where ContainerSSH will fire all the containers that will be spin up. And as you can see, nothing comes up. So what I will do is simply as that and brace with it. Bear with me for the demo gods. So as you can see, ContainerSSH has started something. It runs and I'm logged in. All right. What happens under the hood is this. So this container SSH has started 3 different containers into the same pods: Mokun, MySQL, and MyShell. What it means is I can do something like this: root-p-s host name, and that's it. Let me get the password. Obviously, simple one. There we go. And I have my MySQL. Show databases. Sorry. Oopsie. And there we go. Again, all started by ContainerSSH itself. Let's start something funny like curl http localhost -21/posts. And as you can see, this is Mokun started. When I finish playing with my tools, what I can simply do is this, log out. And as you can see, automatically, the whole environment that I built using ContainerSSH is then automatically deleted. This is it for the very short demo. Obviously, there's a lot of stuff that you can play with ContainerSSH. So please go to the project, look at it, contribute, and have fun. And that's it for me, I guess. And I'm right on time.
Excellent.
Bugger, no gong for you. Okay.
No goal for me.
He is ready.
Ding.
I was
All
looking
right.
forward to a longer demo.
Y'all who are watching, please ask your questions. We're going to answer them in a first come, first serve basis. So get them out there. We have a lot of container SSH questions, or confidential containers, excuse me, although we have some questions for both. I guess you might need help deciphering this question. Solutions like CloudWatch, Application Inside, Datadog, etc., can read your data and logs. Maybe this is about your assertion that stuff that your cloud provider can read what's happening, what you're doing.
Right. I think the answer to this question is like with confidential containers, a lot of the existing like daemon set, there is this pattern. Like we have agents like log collection or metric collection running as daemon sets on each nodes. So in this case, like how your logs and metrics are exposed to these daemons is something we have to rethink. Like you can have sidecars which are directly sending logs and metrics, but then you'd want to figure out if it is safe to do it. Like what kind of information you're putting in as logs, and what gets stored on these, or if you're using services like Datadog, do you want them to have like if they offer like a on-prem your controlled appliance and not having to send data to somebody external, right? So I think that's where you have to some patterns have to change with confidential containers.
Yeah, so it's kind of like locked by default, and then you can enable certain traffic, right?
Yeah, you can choose to. Yeah. Although, like a lot of these questions are not solved yet. Yeah, which the community still has to figure out.
So again, so we can read the logs and metrics and data if we want to. It's there, but with confidential containers.
In the end, that's what I'm thinking. When you install or deploy applications in confidential containers, how the data that goes out, since these metric collections is happening from within, using sidecar running within that enclave, right? So that enclave can still read that data. So if you choose that your data should go to this third party, then that's you're choosing, you're opting in to do that. But something running as daemon set wouldn't be able to get all that information. That's
got it. I'm going to skip to a container SSH question. Can you use container SSH to connect to an existing pod, or does it have to create its own pod?
So basically, container SSH fires new pods, well, a new pod where it triggers new containers. It might be used, I think, I haven't played it with the kind of behavior yet, but it should be usable to debug an existing one. I mean, the basic ID is connect to the SSH server, get the configuration tells fire up this and this and this and this and this, and then you are able to leverage them. So in the end, I think the answer is yes. Yep.
Excellent.
What would be sorry, I have a follow-up on that one. What would be the most common usage of container SSH? Would it be kind of some kind of ephemeral environments, or what do people use it most for?
Environment, ephemeral environment lab, yes. Bastion, when you don't want to have all the people that get connected to the same server via SSH, meaning they get connected to a SSH server and then it fire ups their own environment so that they can do their daily job. Debugging tools that you can leverage automatically without leaving the pods running, let's say for days and weeks. There's a lot of different ways to leverage container SSH. Actually,
nice.
Yeah.
Cool. So Suraj, so you got to talk a lot about what is confidential computing, but I don't think you got into what is a confidential container.
This is cheating. This is Whitney extending your time. You have 1 minute.
So basically, all the goodness of confidential compute that you saw, we are bringing it to Kubernetes, and so each workload or each pod gets its own enclave. It is backed by this runtime called as Kata Containers. So Kata Containers is a lightweight VM runtime. So instead of creating like a runC based, using Linux kernel technologies, like creating this runC based processes, it creates a VM. And this VM is where your processes run. So the community has extended Kata runtime with all these features to start up confidential containers. So when you start application, all you have to do is change the runtime class in deployment or pod spec, and then Kata knows how to. Yes, I was going to show that in the whole diagram, like how containerd does that. But it's okay. It's okay. So in a sense, confidential containers is confidential compute for Kubernetes pods.
So from the end user perspective, so there is a person who sets it up and what's not, right? But for the end user, kind of no change in terms of, I'm still having my pods, which happen to be secure in a way, right?
Well, yes and no. Like an end user can choose to just do a lift and shift if they just want to say, oh, my application just needs encrypted memory. But if they really want to have confidentiality, for example, let's say you're running some application that needs access to whatever service. Now, this service credentials if they're coming from Kubernetes secrets, then that's not secure enough from confidential point of view, because people can still having access to the node can still see it. It has to come from somewhere. So this whole attestation process has to happen before the pod comes, and then you get a secret from somewhere, from a trusted source. Now, this trusted source could be hosted anywhere. And so some mechanism has to change. Although the community is working, there is a feature where you can still use Kubernetes secrets, but you have to prep it up. As in, you prep it up using a signing key, and then you encrypt the secret and store it in Kubernetes, so that even if somebody gets access to the Kubernetes secret, it's encrypted and only accessible after the enclave comes up, attestation happens, and then you get a key to decrypt it. So there is a feature you can do it transparently for users, but not everything is lift and shift. You still have to prep it up, beforehand.
Is confidential containers a CRI implementation? A container runtime interface?
Yes. Yeah. So Kata is the project on which we extended Kata. Kata already has a CRI implementation called Kata runtime. So instead of the traditional containerd runC, it's containerd Kata runtime. So Kata runtime knows how to talk to the virtualization software and bring up VMs. So yes, the answer is Coco is using a CRI implementation.
It's
I
my
like the name
understanding
Coco.
that, yeah, Coco. It's my understanding that confidential computing takes specialized hardware. Is that correct? Where does that come into
That's
play?
that's correct. Yeah. So this is, yeah, it needs specialized hardware. There is an effort. There is effort from AMD and Intel to enable Linux kernel to start these specialized VMs. So this is an effort, like, right from the firmware, hardware, operating systems to virtual machines. So yeah, you need specialized hardware, and also things are coming in Linux kernel, so you can use it right from the kernel that is available.
So once you have the specialized hardware, you don't need to think about the specialized hardware. You just use the processes that's directed. But it's
Yeah,
important
yeah.
to have that. Yeah.
And going forward, it will become more available everywhere. Like it could get to a point where this becomes a default and not a feature. So I
Uh-huh.
think that's the ideal world we would wanna be in. So yeah.
Right on. We kind of answered this, but maybe you can paint a picture, Rashid, for Container SSH is a tool for debugging purposes mostly. So you talked about other use cases too, like a lab environment or Bastion.
Yeah.
But
Um,
do you want to talk about for debugging a use case where it might be especially good?
the tool is not the tool itself is not built to debug, let's say, out of the box the Kubernetes clusters where it runs, but you can leverage it to deploy containers that has all the debugging tools that you need. Something that you probably should not be doing, but like firing a container that uses privileges to access the underlying Kubernetes API server so that you can manage it. I wanted to demo the K3K project from Rancher, which is K3S into Kubernetes itself, but it failed for different reasons. But this is the kind of usage that I saw using ContainerSSH. Is I want to try Kubernetes. I don't know how it works. I want to build a few Kubernetes clusters in my machine. Boom.
Cool. And then another Container SSH question: does it work with other tools like VS Code, Remote SSH?
As long as the tool that you're using has an SSH client, it works. This is as simple as that. The only requirement to use Container SSH is an SSH client. And if you want to do authorization and authentications, then probably leverage other tools like Keycloak, for example, that you've spoken about before. But the minimum requirement is SSH client. Whatever the tools you want to use, as long as it has SSH client, it's fine. As simple as that.
So this happens often on our show when we pit tools against each other that can actually work together. So can confidential containers and Container SSH work together? Yeah.
Absolutely.
What might be a good, yeah. What might be a good use case for that?
Yeah.
Can either of you think of one?
I don't know about the use case, but that can work as long as you can change runtime class in a pod spec, and pod is the basic unit of application in Kubernetes, and Container SSH is bringing up pods where you can update runtime class. So yeah, you can.
One topic where both can be useful, to put it simply, is when you want to get access to a confidential environment and you don't want to probably leave, let's say, pods running or containers running because you have finished what you're doing. This is where Container SSH, I guess, can go up to confidential containers to say, hey, I'm in a critical and let's say classified environment. I just want to get connected, do what I'm doing, throw the logs somewhere, and that's it, out.
Calculate the nuclear launch codes, and then I'm done. Yeah. Here's a Coco question. Do all containers need to run as confidential containers, or can it be selective?
No, that's the whole idea with Coco. Like you choose what you want. That's where the whole runtime class that I'm saying, right? Like once you install confidential containers on your cluster, using there is a Coco operator. So if what it does is that it creates these runtime classes. It preps all the worker, or not all, like or the worker nodes that you choose, that these worker nodes are assigned or have specialized hardware and can run confidential containers. It creates runtime classes. All the worker nodes are prepped with the required things like QEMU and Kata runtime and all of that. And then you can deploy workloads by changing runtime class, and then that's about it. Not everything has to be confidential containers.
Awesome. And with container SSH, can we create any kind of Kubernetes resource or just pod?
Sadly, ContainerSSH, for as long as I know, only runs pods. You can trigger the creation of, as I said, Kubernetes in Kubernetes pods, so that you can have your ephemeral Kubernetes, let's say, lab platform. But you will not be able to create, let's say, from ContainerSSH itself, service accounts or CRDs. You have to go through another container that has the tools, and from those tools, then you are able to create different resources from Kubernetes itself.
So you can spin up a pod that takes care of
Yep.
doing whatever you want it to do.
Yeah. You can automate all the things, just firing a pod, and this pod will automatically create service accounts, for example. Yes. Absolutely.
Cool. And then does confidential containers bring any limitations to Kubernetes?
Besides secrets, which we could.
So they do, right? Like I was gonna also, if I had time, talk about drawbacks.
Dong, 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 dong.
I was gonna talk about drawbacks. Like in general, like confidential compute has some performance overhead, but that's like single-digit performance overhead. That and like in terms of specifically about Kubernetes, right? So you cannot use all those features where you rely on the underlying worker node. So I can think of features like host mounting, for example. You don't trust the host. That's the whole idea. Anything outside that particular pod is untrusted. Always think that they're trying to do something and something wrong or nefarious with your data, or trying to read or whatever. So with that kind of paranoia, you don't want to use anything outside the enclave. Everything has to come from external third party, or not third party, but external party which you trust. So it's like you are in an untrusted world, and your pod is trusting something outside that you control. So that's why all the limitations that come with this assumption. So anything coming from host, anything coming from Kubernetes API itself, like secrets or even config maps. Ideally, you wouldn't want to have anything important in config map, but if there is a configuration that can change the behavior of your application based on config map, that shouldn't come from Kubernetes. So there are limitations like these. I think any software, security software with enough paranoia has these limitations.
The zero trust. Here's a question for you, Suraj. Are there any other main points about Coco you want to discuss very briefly that you didn't get to because of the 5-minute limitation?
So
this is such nepotism. This is okay. Go for it. I'm giving up.
Sorry and thank you. Okay, so I'll say like the takeaway today that you want to go with it is like confidential compute. Think of it as encrypted memory. Anything, anywhere you think if your memory can be read, if somebody has access to the host and they can read memory, I think those applications should run in confidential compute. And confidential containers is the project that is bringing confidential compute to Kubernetes for each workload. And Kata containers is where all this work is going on. And yeah, attestation, remote attestation that we talked about is super important. You cannot just trust like, okay, I got the hardware, I got everything is trusted. You have to do attestation to ensure you're really in a confidential compute hardware enclave. So yeah, that's it.
You have to look in the mirror and trust yourself too.
And that too, yeah, for sure.
What approach do you use to upgrade with confidential containers?
Is that like upgrade the underlying hardware, or
I'm
like
guessing
upgrade your Kubernetes cluster? Yeah.
So
AWS EKS, yeah, or Azure AKS clusters.
Yeah, so I mean, I cannot talk about the offerings since we're talking about the open source projects. But if this is like with if you're using the Coco operator, it's a matter of updating the operator, and then it takes care of installing all the latest bits. But if the question is around like how do we use with these managed offerings, I think it boils down to how they choose to do the updates.
All right. And then a question from Barun. Can Coco containers work with existing Kubernetes security contexts like seccomp? Do you think there's a valid use case to have this, or Coco is sufficient in themselves?
I think Coco is sufficient in itself because seccomp is designed. So first of all, the default applications or the pods that you start are runC based. So runC is like yet another process, and you're trying to isolate it from what it can do. And seccomp is doing that, right? What extra it can do on top of the regular permissions it has. You're trying to restrict what syscalls it can call and all of that. So I think with respect to Coco, it is running in its own VM. So it is pretty isolated on. So yeah, so somebody has to break out of that. So even within that VM, it is running in runC. So if you want to further isolate that applications, sure, we can use seccomp, but it doesn't affect anything on the worker node because there is VM inside the worker node that's running.
Excellent. And that's our last question. So now we're to the part of the show where you each get a couple of sentences to say one more plea for why we should vote for your technology. So since you presented first, Shiraz, you go first, please.
Okay, so yeah, I think security is a layered approach. You cannot get enough of it. And this is like your data, like think of various places your data will be exposed. And when you think of like memory is one more place where data could be exposed, you would want to have it encrypted. So if you really want like the comprehensive security that any technology can offer, I think confidential containers and Kubernetes is the one.
Excellent. Thank you so much. Thanks for sharing your time and your expertise with us. All right, Rashid, why should we vote for ContainerSSH?
Wow, tough question. One main aspect that I see is when you have, let's say, hundreds of developers running in your own company, and each of them want to have its own Kubernetes clusters. What I like into ContainerSSH is that it allows very fast to spin up those hundreds of clusters out of the box. And when you don't need them, just delete them. It's flexible, very extensible as well. And as I said, it's not about only developers. You can use it in highly secure environments as well. So this is definitely a tool that I would suggest the community to dig in. Yeah.
Excellent. Thank you so much for sharing your time today.
Cheers.
Bye. See you at KubeCon. And that's a wrap.
That's a wrap. Yeah. Yeah,
so
vote. It's in the description. The link and by the way, again, the note from the last episode. If you go to the link and you cannot see, there is a second link in the description where you should register, but you should register only after you spend 3 minutes feeling ashamed for not being already in CNCF Slack. First comes shame,
if you're watching this
then
show,
register.
You should be in the CNCF Slack. Look in the mirror. Feel ashamed. Trust yourself. Feel ashamed. Votes. Excellent. And then if you're at KubeCon and you see Victor and I around, please say hello. I'm going to have you choose stickers, and I'll make sure Victor has some on him too. So ask us for a sticker. Come see our talk on Wednesday. Our talk's on Wednesday at 3:15 or something like that.
Yeah, we can. And I'll be signing books.
Oh, nice. I'll get your
Wednesday.
Yeah.
Wednesday. So.
And on Friday, we're doing the final episode of Chapter 3, all about security. It's going to be just me and Victor. We're going to do it live at KubeCon, but we'll also stream it. And we're going to we're going to talk about every single tool we've touched over these last several months and implement all the ones that you chose into one big demo of everything. It's going to be fun.
Exactly.
Yeah. Awesome.
Yeah.
Thank you so much, everyone. Have a wonderful rest of your day. Bye.
Wait, now I need to press the button.